Again, welcome to Python programming language. In these lectures, we're going to discuss how to use break and continue keywords in a loop. Example, either for loop or while loop. Mostly it's used in a while loop. So what break means is that we have a condition that we want to execute a loop from 1 to 20 times. But we have a condition that if that condition is met, we will stop the executions. So let's say we execute up to 10 times and the condition is met and we have a break right below the condition, which means we are going to come out of the loop. Instead of executing from 1 to 20, since the condition was true, when we reach 10, we are going to move out of the loop and stop the loop. Now, continue means, let's say I want to print values from 1 to 10, but I don't want to print 6. So I may have a condition that if the loop reaches 6, we should continue, which means I'm not going to print the 6, we skip it. So the difference between break and continue is that break will stop a loop. Continue will skip a task in a loop, and then we continue. So let's see an example here. Hopefully this example may help us more. So we can see that we have a program here. This program is telling us that we should, again, this program, example of using break and continue keywords, break and continue keywords. So in this example, as we said, we are going to add numbers from 1, actually from 0. Let's say the initial counter start from 0 up to 19, because we say from 0, the number is 0, while the number is less than 20. We increment the number by 1, then we add the number to the sum. But we have a condition here that's saying if the sum value is greater than or equal to 100, we break. So this means most likely we are not going to execute this loop 19 times or 20 times. From 0 to 19 is 20 times. We only execute this loop 20 times, that's from 0 to 19, if this condition, each run, the condition is false, which is if the sum is greater than or equal to 100 is false, then we keep executing the loop. But if the condition becomes true, we have a break keyword below, which will stop the loop. Then we are going to print the number is whatever number we have where we reach, and the sum is whatever sum we have. So again, first we have a variable named sum. This is where we are going to put our answers. We initialize it to 0 to make sure there's no any value inside. Our counter variable is name is number. Also, we always initialize it, because that will be the beginning of the. So for example, if I say number is 5, then that means the execution will take place only 14 times from 5 to 19. So here, our counter variable, we start from 0. So first we say 0 less than 20. Yes, okay. If it's yes, we add 1 to 0 and we get a new number to be 1. Then we add the 1 to the sum and we get a new sum. So sum is 0, so our sum will be 1. Then we check, is 1 greater than or equal to 100? No, that's false. So it's still in the loop. We cannot execute the break statement. We only execute the break statement if the condition here is true. Sum is greater than or equal to 100. Then whenever the condition here becomes true, we come out of the loop, we print the last number we have, and we print the last sum we have before 100. Before 100, it will execute. So the sum value, in order for this condition to be true, means we are going to get at least the sum will be 100 or more. So let's try the animation. Hopefully that will help us to understand. So first, when we run the program, we initialize the sum variable to 0. We also initialize the number to 0. Now we check, is 0 less than 20? Yes, that's the condition. The loop continuation condition, number is less than 20 is tested. And since 0 is less than 20, then we are going to execute. We add 1 to the number. Then we say 1 plus sum is 0, so sum will be 1 now. Then we test the condition. Is 1 greater than or equal to 0? No. Then we are still in the loop. So now we are testing with 1. Is 1 less than or equal to 20? Yes. Then we add 1 to the number. It becomes 2. Then 2 plus, our previous sum is 1, so our new sum will be 3. Then we check, is 3 greater than or equal to 0? No, that's false. So we are still in the loop. So we check, is 2 less than 20? Yes. So we increment 2 to 3. Then we add 3 to the previous sum is 3, so our new sum will be 6. Is 6 greater than or equal to 100? No. So we're still in the loop. So we test 3 with less than 20? Yes. So we had 1 to 3, we get 4. Then we add 4 to our previous sum, which will give us 10 now. Is 10 greater than or equal to 100? No. We are still in the loop. Is 10 less than 20? Yes. So we increment to 5. Is 4 less than 20? Yes. We increment the number to 5. Then we add 5 to the sum, which is 10. So it will be 15 now. Is 15 greater than or equal to 100? No. We're still in the loop. Now is 5 less than 20? Yes. We add 1 to it, we get 6. We add 6 to 15, we get 21. Is 21 greater than or equal to 100? Yes. If it's yes, then we break. But it's no. 21 is less, so it's false. We're still inside the loop. So we check 6 less than 20, still also true. So we're still in the loop. We increment by 1. Then we add 7 to 21, and we get 28. Is 28 greater than or equal to 100? No. So we're still in the loop. Now we check 7 less than 20. Yes, we're still in the loop. Now we have 8. 8 plus 28, 36. Is 36 greater than 100? No. So we're still in the loop. We check 8 less than 20. Yes. We increment by 1, 9. 9 plus 36, 45. Is 45 greater than or equal to 100? No. So we're still in the loop. Now we check 9 less than 20. Yes. We increment by 1. 10 plus 45, 55. Is 55 greater than or equal to 100? No. So we check 10 is less than 20. Yes. We increment by 1, 11. 11 plus 55 is 66. Is 66 greater than or equal to 100? No. You're still in the loop. So now we check 11 less than 20. Yes. So increment to 12. 12 plus 66 will give us 78. Is 78 greater than or equal to 100? No. So we're still in the loop. Is 12 less than 20? Yes. Increment by 1, we get 13. We're almost done. We had 13 to 78. We get almost close 9, 91. Is 91 greater than 100? Greater than or equal to 100? No. We're still in the loop. 13 less than 20, yes. We increment by 14 from 13 to 1, 14. Is 14 plus 91 will give us more than 100 now, which will give us 105. Now our condition will be true. Is 105 greater than or equal to 100? Yes. So remember, this loop executes only 14 times. Supposed to be 20 times from 0 to less than 20. That means from 0 to 19. That should be 20 times. But because of the break statement, since 105 is greater than 100, we break from the loop. So our final, and so here they say which line will be executed. It will be line 10 now, because we come out of the loop. The break statement stop the loop. So you are correct. So the answer will be the number is 14 and the sum is 105. The sum is 105. So again, this is how we use the break statement. We have a loop. Inside the loop, we may have some condition. Always there must be a condition because either the condition is true or false. If the condition is false, we skip the break. If the condition is true, the break will execute, which will stop the loop. Now, if we have continue, it means if the condition is true, we are going to skip. Then from 14, we can go 15, we can go 16. A continuous statement will not stop the loop. It's only we skip. For example, if we are using continue here, really doesn't make no sense because, for example, I have sum, and the last sum we have before, let's say somewhere around 90 something, 93 or 93, I think 93 or something. Now, 93, it will add. When they reach 105, if the condition here is continue, what will happen is that it will say 105 is 105 greater than or equal to 100. Yes, so it will skip, continue. So the the next number, which is 14, is not going to be added. So we skip this condition. Then we go over 14, 15, 16. The only thing we are going to skip. But again, as I said earlier, I won't use continue in this statement because really doesn't make no sense. We just skipping when the sum is over, but already we added the sum. Then why do we skip? But the whole concept of continue is that based on the conditions, it will skip. Actually, we have a nice example in the slides here. So this is the same example for the break that we just went through. But this is a nice one for continue. Here we want to add some numbers. But see what we are doing. We are saying that if the number, that's if the counter reach 10 or the counter reach 11, we want to continue. That means we are going to skip. We are not going to add 10 and 11 to the sum. But still, the execution will start from 0 to 19. So what we are doing here is that we are adding the numbers 0, 1, 2, 3, all the way to 19 till the number is less than 19. But when we reach 10, we skip. We didn't add it. Then when we reach 11, we skip also. Continue. We didn't add it. So that's what we say. Jump to the end of the iteration. When the condition is true, it will jump. Now let's see one more code here using the break statement also. So here, this program is again for guessing a number. We can write this program using a break statement. Actually, in our previous lectures, we wrote this program when we were studying the selection statement. So let's try that program first before the next one. So here we are going to guess a number. So first, we are importing the random class because we want to use the runInt function to generate the random numbers. So here we are going to generate any random number, a whole number. We are using the runInt method, generate a whole number. And here we specify the whole number is between 0 to 100. So when we generate the number, we assign the number to a variable name number. Now we have instruction that we should guess the margin number between 0 to 100, the number that we guess. So there's a condition here saying that while true, which means always if the while condition is true, execution will always take place. Normally in C++, we will say while is 1, or which means it's true, or 0 means it's false. So here we say while true, we prompt the user to guess the number. So the user entered the number using the input function and we convert it to int. We store the number in a variable name guess. So now we are checking our condition. If the user was able to guess it correct, which means if the guess equal to the number, Then we tell the user, yes, the number is correct, or yes, the number is whatever you enter. Then we break. So this means we break from the while loop. We don't need to check the rest of the condition. But if this is wrong, then we check again. Is the number that the user guess greater than the number, the random number? If it is so, we tell him that, hey, your guess is too high. So we are giving him the hint that he should enter a number lesser than what he entered. Or if the number he entered was too small, we tell him that the number you enter is too low. So from there, we enter higher numbers, but not more than 100. So here we are using the break statement here so that anytime the user gets it correct, we'll stop. Now, if the user didn't enter the correct number, we can see the two next conditions. There's no any break or anything. So which means we're still inside the loop. This loop is a condition is true always. So the only way this loop will stop is when we get the user get the number, the guessing number correct. So here you can see in this while loop, we don't need a counter. We don't need to initialize anything. When we write a statement, while true, it's more or less like infinity loop. It's always going to be executed. So we are using the break statement to stop it. So what this program will do is that anytime a user who gets the number inside the while loop, the user can enter as much as he can. Anytime the loop executes, user will guess the number. If user gets the number correct, then we break. We come out of the loop. If the user didn't get it correct, then it's coming back to enter the number again. So you keep entry until you get it correct. So let's see the line code. Again, this is how this program will work. Here we don't have the animation for it. And they're running the example live again. It doesn't work because this is a crowd system, but for some reason, it's not been working for long. So, oh, okay, it's working now. Okay, so that's the source code we just went through. First, we generate the random numbers using the runInt method. We import the random class. We guess the number already. We have the random number. We ask the user to guess the number. User enter the number, and we check these three conditions. Either the user have the right number, which means he guesses correct, then we break from the loop. Otherwise, the number will be either greater or less than the guessing number, the random number. So let's run this program. I click on run here. I'm not sure to run, but let's see if it will run. Oh yeah, okay, it works now. So here what happened is that when we run this program, your program state to run out of, okay, it's not working. It's not working. Let's reset it. Oh. Yeah, no, it's not working. I was surprised. Look like it's working. So but again, that's the whole concept here. We can give a try on it. Again, in the class, we are going to pause this video and then we can write this code and run it and see how it works. Again, here we cannot, give it may have infinity. Hold on first. Seems like some execution. It's supposed to ask me to enter the number, but I can't see the box to enter the number. No. Normally a box will come. Oh, okay. Let's try this. I think it's giving me the command prompt. So I'm just going to enter any number. I don't know what number the program, but I don't think this will work, but let's give it a try. No, it's not working. Okay. So that's our second program. In the class again, we are going to run this code and see. The main goal here is that we are using the break statement to control our loop. If we have a loop while true, this loop is infinity loop. There's no condition to stop it. So the only way we can stop it is using the break statement. Also, we are going to check if a user enter a palindrome. A palindrome will be a string that if you read it from left to right or right to left, it's the same. So we have the definition here. A string is a palindrome if it reads the same forward and backward. So example, mom, M-O-M, forward, backward, the same thing, M-O-M. Dad, D-A-D, or noon, N-O-O-N. If I read it or spell it backward, it's the same thing, N-O-O-N. So a palindrome is any string or any word that when you read it forward and backward, is the same. Now here we say that the program is to write a program that prompt the user to enter a string. Then when the user enters the string, we are going to report whether the string is a palindrome. So one solution is to check whether the first character is the same as the last character. If so, then check the second character is the same as the second to last character. As we can see here, first character M is the same as M, but again, we have only 3. So for example, 4 character N, N, O, and O. So the first character is the same as the last character, and the next second character is the same as the last second character. So if they are all the same up to the end of the characters, then it's a palindrome. As we can see here, first we check with A and A, it's okay, then B and B, then C and C. So let's see the code. So first we're going to prompt the user to enter a string. So we have the instruction here. Again, here we don't need to change because anytime we use the input function, as we said earlier, the data type we get is a string. Even if we enter a value, it's a string. So we normally use the int, float, etc. to convert it. Here we are going to compare the characters as a string. So we ask the user. Now, when the user enters the string, we are going to store it in a variable s. Then the next thing, we are going to check the index of the first character in the string is always 0. It's like an array. If I have a string characters 5, the first character is 0. Then the last 5th character will be 4. So we start with the lowest. Then of course, the last character will be what? If it's 5 characters, the last character will be 4. So here we say the higher will be the, now we have a method. When we cover strings, we may functions, we may go details on this. The len is a method that gives us the number of characters we have in a string. So the string that I enter S, here is telling me how many characters I have. But if the characters are 10, then the index is from 0 to 9. So that's why we say len S minus 1. So the variable low and I is telling us the first character and the last character. So now our condition is that we have a method is we are assigning the variable is palindrome is true. Now this condition means while low is less than high, which means we haven't reached the end of the characters. Because remember, if we start from the first character index will be lower than the second character, will be lower than the last character. Last character is the highest. So when low is equal to high, it means we have only 1 character. So here we are checking, we have at least 2 or more characters, while low is less than high. Now, if S low is not equal to Si, our first condition, we are checking if the first character is not the same as the second character, then we stop. There's no need to check if it's palindrome. So we assign false to its palindrome, then we break. No need to check again. Now, if this condition is false, that means the first character is the same as the second and the last character. First character is the same as last character. If that is the case, we are not going to execute the break statement and the to statement here. Rather, we are going to increment, we move from the 0 to index 1. And the last character, if it's 5, we move to 4. So that's why here you can see that we increment the low to 1 and we decrement the high. And we're still in there. Now, let's say low was 0 before, now it's 1. The characters are 5. So before it was 4, now it's 3. So we check the index number 2 and number 3, and we keep going. But if the first character and the last character is not the same, then we break from the while loop. It's not palindrome. We assign false, it's not palindrome. But if the first character is correct, then we check the second character. Then we come and check the condition, second character and the last second character. If the conditions are true, we move to the third character, then we move to the last third character also. So for example, if it's 10 characters, we'll move 0, 1, 2. The other one will be 9, 8, 7. So we compare 2 with 7. Next time we compare 3 with 6. Next time we compare 4 with 5 until we reach. If they are all the same till the last character, then that is palindrome. If along the way this condition become true, then it's not palindrome, then we break. But if all the condition is true, then here we are going to print that it's palindrome. Or if it's not palindrome, we break, then we're going to print it's not palindrome. So that's the whole concept. Again, to check if a string is palindrome, as we said earlier, we have a word. When you read it forward or backward, they are the same, which means the first character and the last character must be same. The next second character and the last second character must be same. The third character and the last third character must be same. So that's what the code will be checking. And we are using the variable low and high because we can see we initialize low, that's the index of 0 beginning. As we said earlier, if we have 5 characters, the index will be 0 to 4. So the high will be number 4 index. We use the method len to get the length of the characters. They are 5. So the index will be 4. 5 minus 1, 4. So from 0 to 4 means 5 characters. Then we start to check the first and last. If it's the same, increment the first to 2, decrement the last 4 to 3. If it's the same, then it's only 5 characters. The middle one we don't need to check. They are is palindrome. Also, we are going to go through a program. This program also uses a loop. The reason why, because we are going to display prime numbers. We know a prime number will be numbers that you can only divide by itself and 1. So for example, if I have 50, what will be the prime numbers for 50? 2 will be a prime number because we can divide 2 by only 1 and 2 itself. There's no remainder. Can a 3 be a prime number? Yes, 3 is a prime number. 5 is a prime number. 7 is a prime number. Is 8 a prime number? No. Because 8 we can divide by 8 and 1, but also we can divide by 2 and 4, and the remainder is 0. A prime number is a number that you can only divide by itself and 1, and there's no remainder. The rest, if I divide 7 by 3, there's a remainder. If I divide 7 by 4, 5, there's a remainder. 6, there's a remainder. 7, I can only divide by 1 and 7. There's no remainder, so it's a prime number. So how do we solve this problem? Here first, the program can be broken into the following tasks. For numbers 2, 3, 4, 5, 6, we need to test whether the number is prime. Now we need to determine whether a given number is a prime, then we count the prime numbers. So for example, 13 may have, 13 is a prime number, and how many prime numbers you can get from 13? It's only 13. 50, we can get more than that. The goal here is that we are going to write a program that, for example, if I enter 2, how many prime number I will get up to 2? Only 1. Actually, if I enter 13, I may get the prime number for 2, 3, 5, 7. 8 is not good, 9 is not good, 10 is not good. 11, I think 11 also is good. 11 is good. 12 is not good, 13 is good. So let's see how this program works. Let me go back. So let's see how this program works. So first, the number of primes we can go here, we want to display up to 50. So the number of primes to display is 50. Then the number of primes per line should be 10. So we'll get 5 lines. And we are going to use the variable name count. We initialize it to 0. This will count how many prime numbers we have. So for example, if I enter 13, maybe I have only 5 or 6 prime numbers. If I enter 50 or 70, I may have more than that. So print the first, this program is going to print the first 50 prime numbers. So which means we are going to use a loop. And we'll say this loop is going to run 50 times. So we counter start from 0 and it go to 49. So we assume the number is prime. So we have is prime is true. Now we test if the number is prime, which means the divisor we have 2. And here we say why. So here we can see that we have a nested while loop. First, our count, we are going to execute 50 times. Find prime numbers from 1 to 50. So while divisor is less than or equal to number divided by 2. If the number modulus divisor equal to 0, which means if we divide the number by the divisor, which we have 2, and then if true, the number is not a prime, because it's an even. Actually, even numbers cannot be a prime number. All the prime numbers are always odd numbers. So that's the first thing we check. Divisor is 2. If y divisor is less than or equal to the number by 2, if number modulus divisor is equal to 0, then if this condition is true, then it's not a prime. We break and then exit from the program. But if it's prime, we count it. Again, we are inside the loop, while loop. So every round we're going to count. We increase the count. Then we format our output we want, because remember we say 5 in a line. And then count modulus number of prime per line equal to 0. Then we display the number and advance to the new line. We create a new line. Then we check if the next number is a prime number. We increment. We're still in the for loop, so we will execute this 50 times. The first 50 prime numbers. And number of primes, again, we have the variable 50, number of prime numbers. So let's see the animation. Hopefully this one will work. We start the animation. So first, our execution, we have our 2 variable. Number of prime is 50. The number of primes per line actually is 10, as it said 5. So we're going to have 10 per line. And this statement, we initialize our counter variable, and the number we start from to test for primeness. Because we know a prime number is not an even number, it's always an odd number. But not all the odd numbers are prime numbers. So example will be 9. 9 is a odd number, but is divisible by 1, and 9 also by 3. But 7 is an odd number, it's a prime. 13 is a prime. 11, yeah. So here we execute first, we initialize our count and number variable. Now the statement we check if we reach 50, the count of course we just start from 0. So this is true. Then we assume its prime is true from beginning. Now we need to test it with the divisor. The question here is what will be its prime after the for loop is finished. After the for loop is finished, what will be its prime here, which I was supposed to say after the while loop is finished. So here we have the divisor start from 2. We check with the divisor if it's less than or equal to the number modulus number divided by 2. Remember the count variable the number is 2. We start from 2. A number to be tested for primeness. Number is equal to 2. So divisor is 2. And we say, okay, if 2 less than or equal to 2 divided by 2, which is true, then the number, which is originally 2 modulus, and the divisor 2 equal to 0. If true, the number is not prime. Then, so in this case, the number is 2 and divisor. So we have 2 modulus 2. The answer is 0. So this condition is true. And we say if it's true, then it's not. Then we exit from this and we go and check the next value. So here they say what will be is prime after the for loop is finished in this area. That will be false. So its prime is true. Let's see. Maybe I'm missing something here. The statement determines if the number of prime, if the number is prime. It is prime in this case. Let's see why it's prime. So we test if the number is prime. The divisor is 2. So we assign 2 to the divisor. And here we say that y divisor is less than or equal to the number divided by 2. And here the number is 2. The number to be tested for prime is 2. And the prime, and if true, the number is so here we exit from the loop if this is false. But it's prime, okay. So for example, from the beginning here, we can see that we have our condition and we assume its prime is true. So its current number prime is true. So here, test if the number is prime. And so here we are asking if its prime is true, which again is true. Then we test here, display the prime number, increase the count. And we keep doing this. Again, the whole concept of its prime is that the answer will be odd numbers and any number that divide by itself and 1. And that's what we are checking here, dividing by 2. So again, that will be the conclusion for these lectures. Again, the whole concept here is to use the break and continue, and also to see some few loop examples in Python. So again, wish everybody the best.